This is Dr. Lewis going through material that will be covered in the assessment, which is replacing the written exam. So remember, my course is on structure and bonding, and a key thing to remember is that the lecture course, the only lecture course in this module, was rewritten from previous years to concentrate more on organic chemistry. So some topics have been omitted that you will see on past papers. So you'll see questions on past papers on VSEPR. There will be no VSEPR questions. There are also questions on molecular orbital diagrams of simple molecules like oxygen and nitrogen and C2, and again they will not appear. So the topics I will cover in these YouTube videos are what you will be doing in the exam, and it's based on the lecture course. So this particular part, if you look there, it's linked to the L2 file. So if you look for L2, which covers covalent bonding and the orbital approach, we went through the basic idea of the covalent bond and then the hybridization view of organic bonding of carbons. So remember, the problem with carbon chemistry is that we have p orbitals which are 90 degrees to each other, and we have an s orbital which is spherically symmetrical, and yet the bonding around a carbon can be tetrahedral, as in 109.5 degree angle, or for a double bond it will be trigonoplanar, and for a triple bond it will be linear. So how do we get tetrahedral bond angles from orbitals which are 90 degrees to each other? And this is where the hybridized view of orbitals came from. We just have to remember that it's not real, but it is useful. So read those lecture notes, and to answer this question you don't need a huge in-depth understanding. All you need to do is recognize certain bonds have certain hybridized orbitals. Remember that, say for a carbon-carbon double bond, we've removed one of the p orbitals to make the pi bond. Say for that one there's a p orbital used to make the pi bond, and the sigma bonds are made from the sp2 hybridized orbital. So the p orbital is not a hybridized orbital, it's an atomic orbital. We're only asked for the hybridized orbitals. So for double bonds, sp2, for single bonds with all single, 4 single bonds, sp3, and a carbon which has got a triple bond, such as this one, is sp. The only other special case which I've mentioned here is or a carbon with a double bond on either side, which is an alene. So that's in the lecture notes, so I'll just draw a picture of it there. So that's alene. And remember that the carbon in the center has got 2 pi bonds on either side, so actually it's using 2 p orbitals. And I'll just sort of pretend that's one's and the 90 degrees to each other. So it's used 2 of the p orbitals, so the remainder is going to be sp hybridized like a triple bond, but it's actually got 2 double bonds. So that's a really special case which doesn't occur very often. So the thing to remember is double bond sp2, triple bond sp3, all single bonds say it again, 4 single bonds sp3. Yeah, so we'll start at the top. Double bond sp2, double bond sp2, all single, and I'll just emphasize that by drawing in the other single bonds not given. All single bonds sp3, that's sp, and a heteroatom, so it just says of all the carbon atoms. So a heteroatom, don't worry, just because that triple bond is linked to an N doesn't change the fact that that carbon is still sp. Again, an oxygen, I'm not asking you for that one. That one has a hydrogen, so it's all single bonds sp3. That carbon is sp3. Well, that carbon is sp3. And again, that one, sp3, remembering that, just to emphasize it, you've got 3 H's attached there. sp3, 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 sp2, sp2, and there's an H there, so that's sp3. Right, just checking you can still see that. So on this molecule, remember we've got a CH3 at the end, so that's 4 single bonds, so that's sp3, triple bond sp, triple bond sp, double bond sp2, double bond sp2, single bonds sp3, and then this one's to sort of put you off, but it's still a C with a double bond attached to it. It happens to be bonded to this funny looking thing which is called an oxime, which is derived from a carbonyl. So you start from C double bond O, you convert that into C double bond N, and that becomes this strange looking functional group called an oxime. And the last one, all single bonds, sp3. So that's all you are asked to do. Hopefully you'll do that. Okay.